Okay, take two here. All right, this problem's been giving a lot of students difficulty. It's on the practice assignment to prepare for your test. So here is a video to help you. Now there's a lot of opportunities along the way to make little mistakes, and that's what's happening. It says here we have block 1 of mass M1, that's this one. It has a mass of 0.55. It's connected over a pulley, and the pulley is massless and frictionless, so it has no effect on the motion. To the other block, block M2, as shown, the angle of the ramp is 30 degrees, and the coefficient of kinetic friction between the block and the ramp here is 0.4, and the system has an acceleration of 0.6. So we can see the block M2 is accelerating up the ramp, and consequently block M1 accelerates down. They have the same acceleration since they're connected by a light string. The goal here is to find M2. Well, forces and accelerations and masses, so that's Newton's laws, Newton's second law. So I'm going to begin there by drawing free body diagrams of both objects. So for M1, there is gravity down, so we'll call that W for 1. The rope is touching it, so the rope is pulling up. There's a tension. There's only one string, one rope, so there's going to be one tension throughout. It is accelerating down, so I'm going to choose an axis that is oriented with the acceleration and consequently perpendicular. I'm going to make the direction of the acceleration positive. Okay, that's good for that one. Now the other block. M2 will have its weight down. It's touching the ramp, so there's a normal force perpendicular to the ramp. It's being pulled up the ramp by that same tension. That rope touches it. And there is friction here, and it's kinetic friction. It is sliding. So down the ramp, I have kinetic friction. The acceleration of this block is indicated as being up the ramp, parallel to the ramp. Put that a little off to the side. So I want to make my axes parallel to that acceleration and perpendicular. And I'm going to make the direction of the acceleration positive. A is up the ramp, so making up the ramp positive. Over here, A is down, so making down positive. All right, I want to find this M2. Now looking through here, weight, that depends on M2, don't know it. This normal force is going to probably depend on M2. On this weight, don't know it. So I don't know much over here at all. The friction depends on the M, don't know it. The tension, don't know the tension. Can't find much over here. But what about here? Gives me the mass, gives me the acceleration. I can find the weight, and then I can calculate tension. Okay, here I know a lot more. So I'm going to attack this item first. And I think then once I get this T, that T goes here, and I'll see what happens on that side. But let's look at this guy. Sum of the forces in that y direction is going to equal M1 times A in the y direction. Well, I have down as positive. I want it to match my acceleration. So that means I have W minus T, because the T is in the negative direction, is going to equal M1 times A, since AY is the only acceleration there is. AX on this item would be 0 over here, because all the A's this way. All right, I can expand this W, that's mg. mg minus T equals M1A I can solve for t now. T is mg minus m1a, and that's 1. That's a 1. Okay, I can plug all those numbers in. The m provided is 0.55. 0.55 times 9.8 minus 0.55 times 0.6. That's my tension. Plug that into a calculator. My batteries are low. 0.55 times 9.8 plus minus. Right, do I get everything there? Yep. 5. The tension's 5 newtons. It should be less than the weight. The weight is going to be like 5.5 around, so slightly less. Not a big acceleration, so not a big difference. That makes sense. 5.06 newtons. I'm going to keep all that information. I'm not going to round it yet. Okay, what's going on with this block? Well, I just found the tension. There's this FK here. It doesn't tell me what that is. So in that x direction, I now know tension. I don't know this weight. I don't know this either. This y direction, don't know a bunch of there either. So I don't know. Probably got to do both. Well, for friction, I think I remember I need normal for friction. So I'm going to need normal to do this. So I'm going to do the y first. So I'll do that up here. Some of the forces on my block 2 in the y direction is mass 2 AY. In the y direction, I've got that normal in the positive direction. Then here, I've got W is off the axis, so it's in both directions, right? I've got this WY and this WX. I've got two components. So that N minus WY is going to equal m2 times 0 because my acceleration is entirely on this x-axis. None of it is on the y, so there is no y acceleration. That makes things nice. Here I'm going to have that normal is equal to WY, and WY here is the angle that is equal to the angle of the ramp. And that is adjacent to it, so it is equal to W cosine theta. And of course, W is M, and this is W2. I don't want to forget that this is two different masses. So it's M2G cosine theta. That's what N equals. And I'm just going to leave that as letters right now. Okay. Now I can go do my x's, and looks like I got a bunch of stuff for that. So sum of the forces on that second block in the on the x-axis here is equal to the mass of that second block times A in the x direction. What are the forces in the x direction? Positive is up to my left here, so T is a positive. Wx is a negative, minus Wx. Fk is a negative, minus Fk. Anything else? Nope. N is all on the y's. Looking through all my forces, take care of all. A lot of people leave out Wx because they forget W here is neither all on the x or on the y. So it has components on both. So don't forget that. N is not on the y at all. Don't add it in there. This is just the x's. Okay, and that's going to equal my M2 times A, since all of the A is in line with x. All right, let's sub in all my symbols for everything. This Wx is this opposite side, so that's W sine theta, right? So Wx equals W sine theta, which equals mg sine theta. I can put that in there. T, and I know what T is. T is that value there, if I want to do it all with letters, or that number. I'm going to leave it as T. Minus mg sine theta. Fk. Fk is mu kn, always. It's the static friction that's a range. This is kinetic, so it's definitely that value. So that's going to be mu times n, and I calculated n up here. It's m2g cosine theta. So this is mu sub k, m2g cosine theta. All right, lots of little letters everywhere. That's going to go here. Can I fit it all in? Mu k m2g cosine theta equals m2a. All right, those are little side calculations. All right, that's a little messy, but I got my m's in there, right? Here's all these m's. I need to find that m's. So I'm going to put all the m's on the same side. Those are all m2. So I am going to go find, right, because this is weight 2, m2. These are all the same mass, the mass of this block. Going to move them over to the right. So this is now it's algebra. We got that little thing there, but I've got T is going to equal, going to add that over there, m2a plus m2g sine theta, add that to the other side, plus mu k m2g cosine theta. Big mess. Factor the m out. There's an m in every term. I can factor it out. So I have that T equals m2 times the quantity a plus g sine theta plus mu k g cosine theta. Let's double check. A g sine theta mu k g cosine theta. Good. All positive. It's done. All right. Divide that term over. T divided by this big thing, a plus g sine theta plus mu k g cosine theta, parenthesis, that's going to equal m2. Okay, now we plug all those things in and see what happens. My T is 5.06. My A is 0.6 plus 9.8 sine, my angle is 30 plus mu k is 0.4 times g times cosine 30. So let's see if we can do that here. 5.06 divided by the quantity, 0.6 plus 9.8 times sine 30 plus 0.4 times 9.8 times cosine 30. Let's see if I did it right. Boom. So it says 0.56887. This has 3 digits throughout, so 0.569 kilograms. As long as I typed that in right and it followed the right rules, I should be good. I'm going to plug that in to mastering and see if it's right. I'll be right back. did we say? 0.569? Yep. 0.569. Submitting. And bang! Correct. We've done it. Okay, lots of opportunities to screw up, right? Free body diagram of both objects, carefully identifying all the forces. Indicate the direction of acceleration and make your axes line up with that. Make that direction positive. You don't have to do that, but most people screw it up because you want A to be positive because everyone just puts MA. Nobody really writes M negative A because then it looks like M minus A. And then you subtract rather than multiply. There's a lot of reasons why. But make note of that. And then remember to do your forces. The force that's in line with the A should be the positive. The one opposite the A should be negative. This diagram, W is not on the axis, so that means there's a component on both. A WY for the Y's and a WX in the X's. Don't forget that. VW, the original weight, is always the hypotenuse. WY is a component on the y-axis, and WX is perpendicular to that in the x-axis. Be careful of the directions. Read these right off your problem. Right? T was up in the direction of the acceleration, FK is opposite that, and WX is opposite that. Remember, W is mg, and friction, kinetic, is mu Kn. The N is found by adding the forces in the y-axis, which should have no acceleration. One axis will have all the acceleration, if you set this up carefully, and the other axis will have none of it. So make sure only one axis has that acceleration. Okay? A lot of work, a lot of opportunities to make little mistakes, but hopefully this helps. I'll post this online today. Test is in a few days. Hope you enjoyed it. Bye.